Okay. Look, hey guys, come on. I want to start. So, rules of indices, or also powers, if you want to call them that. Yeah? Okay. So to start with, I'll just say x is not 0. So the first rule is x power n times x power m is x power n plus m. Which you all know, or at least you should remember from school. Yep. The proof is very easy. So x n x m, that equals x dot 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 n times. And then this is x dot 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 m times. So in total that's x dot 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 n plus m times in English. So that is x power n plus m. Yes? Got that? No? Okay, so write this down. You don't need the proof for the exam, but it is good to see the proof. So I would like you to write it down. But this is the first rule. Yeah? Got that? Yep. You can probably guess what the second rule I'm going to tell you is. What do you think it is? Yeah, the divide, isn't it? So this is x n minus m. And again, the proof is very easy to do. Xn divided by xm is x dot 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 n times. And then on the bottom, you have x dot 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 m of these. And what happens here is you cancel. And each time you cancel, you lose an x. So in other words, after you do all the cancelling, you're left with x dot 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 n minus m times. So in other words, you're left with x n minus m. So you can cancel the x's on the top with the x's at the bottom, which you know. You got that? Not yet? Okay. Yep. Not yet. Yeah? Yep. Okay. The next rule is x power n power m. And that's x power n multiplied m. And the proof, xn power m, that is, if you want, you can write that as xn times xn times xn. How many of these will I have? M of these. But the first rule tells me the powers add together. So that's n plus n plus n, etc. How many? M. So you know if you have, for example, 2 plus 2 plus 2 plus 2, that's the same as 4 times 2 if you have 4 of them. So likewise, you can say this is x n times m, because you have m of them. Yeah? Tony, no ren, no QQ in class. Okay? Thank you. Alright. Continue? Yeah. Okay, next one. Yeah, the root one next. Do you remember it?
Yeah.
What is it, the rule? X power,
Half.
yeah, half is square root. Third is cube root. So in other words, x power 1 over n is the nth root of x. So like you said, for example, x power a half is square root x. X power a third is cube root x, as an example. We'll do them in a minute. So the proof...
You can add m to the power instead of 1.
Yes. Oh, what do you mean? M here?
Yeah.
Yes, that's true. Different books will write the formulas in a different way. Some books will have an M here and put the M here. That's fine. I don't remember which way it is in the formula book. I'm not even sure if it's in the formula book, but I usually write it like this as the rule. If you want to include the M, you can. That's fine. So the proof is simple. We put power n on both sides. So if you have the nth root power n, yeah, it has to be x. Here you can use the third rule, and it'll be x power 1 over n multiply n, which is
1.
x power 1, which of course is true. So that's the rule 4. Okay, so write that one down. Question up the front, Nina Pony? Question? No? All okay? Yeah? Yeah? Okay, next rule. Can I go down? No, not yet. Yeah? Okay, next one.
X minus m.
That's it? Yeah. X power minus n equals 1 over, or well, it's, yeah, x power n. If you want to write it like this. Yes? So, the proof, you can have x power minus n equals 1 over x power n. The proof's not so difficult, because, well...
Multiplied by x power n.
Yeah, that's what I was thinking too, but maybe just before that, well, sometimes I call it rule 6, but just at the side here, you can call it rule 6 if you like. It's not really a rule, but it's just to make some things clear. So you might want to even call it rule 0. X power 0 is equal to 1. And then, yeah. It's not really a rule, but it's just to make something clear. It's not equal to 0. What about 0 power x? What's that? 0. And what is 0 power 0?
1.
Which is it? So do we use this one
Yeah.
or do we use this one?
The first one.
Math error is correct, yes. So in fact, there is no value here. No value. Okay? You can check it on your calculator, you don't have a value. So now let's go back to this. So here, like you said, we multiply both sides by x power n. They cancel. And here you get x minus n plus n equals 1. X power 0 equals 1, and it's also true. So these are the 5 rules. Some books write more rules. Some books write the rules a little differently. Some books only give 1 or 2 of the rules. But these are the 5 I commonly use in class. Okay, so make sure you have them clearly written down, and we'll have a look at some examples. Can we do some examples? Yep. Okay, so the first example, we'll go with something like, let's say, very easy, simplify b power 4, b power 8. So that's easy. What rule is that? First rule says that this is b power 4 plus 8, so that is b power 12. So that's easy, just to get us started. Let's have a look at something a little bit more difficult now. Now we're talking. So please carefully write that down. You got this? Yeah? Yeah, well, if you hit it on the calculator, you can get the answer. In the exam, they want to see all the steps though, but you can use your calculator to certainly check the answer. So let's have a look at this. Now please everybody listen, because I'm going to say this and then somebody's still going to ask me, okay? So I'll say it, knowing probably later someone will still ask me again anyways. So there are many ways to do this one. The way I'm doing it is just one way to do it. If later you're thinking, I have a different way to do it, I better ask if that's okay. Teacher, I have another way to do it. Is that okay? The answer is going to be yes, as long as it's right. Okay? So I'm just going to show you one way to get to the answer, but there are many ways to get to the answer. Because the order you can use the rules in is your choice. For example, maybe you want to do something with these roots first, or maybe you want to look at this root first, or maybe you want to look at this first. You have many choices to start. Okay, so what do you think we should look at first? The easiest thing to look at first? Which part? Any ideas? The 16 and the 2, I think, is the best to look at first. Because they easily cancel to make what? Just 8 here, isn't it? Now we have choices to make. What to do next? So you want to look at the 16 next? Yeah. Or the 32? Or the 8? We could look at the 16 part next. But you know what, I'm just going to do it a little bit differently just to make it more interesting. I think a lot of people recognize that the root 16 is 4. But let's pretend it wasn't an easy number like that. You know, if I look at this number, I know the answer is 16. But maybe you get a problem like this where it's not clear. So what do you do? Well, what I would do is, you can use your, remember the tree we had? It'd be 8, and here would be 2 and 4, and then here would be 2 and 2. So that 16 is actually 2 power 4. That's what I would do if it was a difficult number. And then what's the 8? You can do the same thing with the 8. What do you get? You get 2 cubed. And I would do the same thing with the 32. I would get 2 power, does anyone know? 5. Now it's looking a little better because there's a 2 and everything. Okay, what should we do next? I think what I would do next is something with the roots. So what power is square root? Square root is what power? Half. And then down below, what power is fifth root? 1 over 5. So next I would have here 2 cubed multiply 2 power, and then when I multiply these together, 2. And then when I multiply these together, it's like power 1. Yeah, just 2. On the top, when I multiply, I add the powers together. So this is 2 power 5, and this is 2 power 1. When I divide, yeah, it'll be 2 power 4. Square root is what power? Power a half. So this is 2 power 2, which is 4. Now I know, like I said, this isn't the only way. In fact, this isn't even the best way. But it's the way that shows you what to do if the problem was really difficult. You want to try and make everything the same. It makes difficult problems easier. Okay, please write this example down. Does everybody have this? We'll have a look at another example now. So in this example, you could use your calculator to check the answer, but in the next example, you can't. Example. Simplify b power minus 3 square root b power 5 over b cubed square root b. Okay. Which part should we look at first? The b or the root, or what do you think? Could look at the roots. That's funny actually, because I was going to look at this part first, because they seem easy to put together. Because when you divide the powers, you minus them. b minus 3 minus 3. So I would have here b power minus 6. Now the root, when you have square root, that's power a half. And here when you have square root, that's power a half as well. Okay, on the top, you get b power 5 over 2, and on the bottom you get b power a half. When we divide, we minus, so that would be b power 6, b power 5 over 2 minus 1 over 2 is 4 over 2, which is 2. So in fact, that's just a 2. And then to finish, we add the powers together and we get minus 4. So if you want, you could write the answer like this as well. Okay, write this one down, please. Got this? Yeah. Okay. Let's look at something slightly different. Can I go down? Yep. Okay. So let's say something like this. Express 2x plus 1 squared over x in the form as ax to the power plus bx to the power plus cx to the power. Yep. Okay. This isn't too difficult. What we do first is we expand. We could use Pascal's triangle. You would get 4x squared plus 4x plus 1 over x, which would be 4x squared over x plus 4x over x plus 1 over x. Which, if you want to be clear, that's 4x squared over x power 1 plus 4x over x plus 1 over x. So you can see here that the power is minus. So you get 4x power 1. Now again, here there are 1s. So what power do you get in the next one? X power 0. And then in the last one, this is like a 1. So this is like 1x power minus 1. Yeah, this is rule number 5, we said, wasn't it? So you've done it. This is now in the form of axa plus bxb plus cxc. Like this. You got this? Yeah. Okay, now time to have a look at some graphs for this. Okay. So I think to make it extra clear, I'll show you this in Excel. So we'll make a graph. There's x, there's y, and what I'm going to do, as an example, is I'm going to graph this function, y equals 2x. So my x's will go up in 0.1s. So we started. Well, let's start at minus 1. And we'll go all the way up. No, let's start at minus 2, more interesting. And we'll go all the way up to plus 2. Oh, the heck happened there? Right, we'll go all the way down to plus 2. Okay, and the y, that's equal to this 2 power the x. So we'll go all the way down. I think maybe some people know what the graph looks like. already, but we'll have a look here. Chart. And we'll make them smooth points. Okay. So when you graph these types of functions, you see they have a smooth increase like this. Now, will this keep increasing, or will it flatten out, or will it come back down? What do you think will happen? It'll keep increasing. It'll get very large very soon. And what about to the left? What's going to happen? It's going to get smaller. Will it go negative? No. In fact, will it touch the x-axis? Does it have a root? No roots. Doesn't touch the x-axis. So it's getting smaller and smaller, but it's never quite reaching the x. And here it's getting bigger and bigger. Okay. Now that was an example with 2 power x. This graph here, 2.7182845945 power x. Pretty similar graph, right? So let me show you this graph. 2.71828182845945. There it is there. It's the same type of graph. But some people maybe recognize the number I used. Does anyone know the number I used? It's actually, I didn't just make this number up because I'm crazy. True, I am crazy, but I didn't make this number up. What is this number? Does anyone remember seeing it before? Yeah, it's E. In maths, this here is a constant, a bit like pi, and later we will see the importance of this constant. But for right now, we're just going to say E is a number which is roughly equal to this. In fact, it's built into your calculator. So what I actually drew for you there is this graph, y equals e power x. And we're going to have a look at this now. But just before we do that, I want you to practice using your calculator to calculate this. So what I want you to do is, using the calculator, let's calculate the first few numbers, minus 2, e power minus 1, e power 0, e power 1, and e power 2. Take out your calculator and find the values of e there. Every calculator should have this. Oh, sorry, I left, I had 18281828459045. Wait, I wrote the number down wrong here. It should be 2.718281828459045. You'll excuse me for not remembering it perfectly, okay? So can you calculate the values here? What's the first one? 1, 3, something like this. The next one? 367, okay. This I know will be 1. This I know will be 2.718. And this one here? 7.38, and so on. Did everybody find this function on their calculator? Did you find it? Yeah. E power x is an important function for us, okay? We will be studying it more later. So there are 4 types of graphs we can have for E. So what we're looking at is graphing things that look like this. A, E, B, X. So for example, here, if I change this to, if I put like for example, something like this, y equals 2 times e power 3x. Something like this. You could use your calculator to make a table, like what I did here, but in the exam, they don't want you to do it. They just want a rough sketch. So I need to show you the four possibilities for what could happen with the graph. So the first possibility is the easy one. A is positive number and B is a positive number. The second possibility is A is negative and B is positive, or A could be negative and B could no. A could be positive and B could be negative, and lastly A is negative and B is negative. What's wrong? I got that positive, 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 negative, negative, positive, negative, negative. What's wrong? What's confusing? No, I'd love to know what's confusing. Ah, picture's not finished yet. So, in each picture, I'm going to do the four graphs. So this is xy, this is xy, this is xy, and this is xy. Okay, so in the first graph, what shape is it? Does it increase, decrease, positive, or negative? It's increasing and positive. In fact, it's just like this graph I made. So in the exam, what they want to see is something which is nearly flat and then increases quickly. And this point here, what's the value of this point on the axis? Look here. A. Yeah? If the x is 0, what's e power 0? 1 multiply a? A. So the A is where it crosses the y-axis. Does it cross the x-axis? No. Okay, this one here, does anyone know what happens if you make the A negative? Yeah, well, it goes down instead because the A is negative and A is where it crosses the y-axis. So if A is negative, it's down here. So it goes under. Just flips upside down. What about here? The A is positive, so I know the A is here. But if the power is negative, it's going to be decreasing. And here, the A is negative, so it'll be down here. And the B is negative. Yeah, well, is it going? Yeah, is it going from down, up, or up, down?
Up, down.
Up, down, up, down, down, left, right, A, B, A, B. Which is it, do we think? So is it going to, do I start from the bottom, or from the middle? Or from the top? Not the top, of course. So it actually goes like this. It's actually an ugly shape. Let's try that again.
So it's a 0?
On the x-axis, never quite reaches the 0. What do you mean 0? Actually.
Value of y.
No, impossible. Yeah, you got that?
Yeah.
Mm-hmm. Now, you might say, okay, so what happens if I had a graph like this? Can I go down? Not yet? Not yet. Can I go down? Yeah. So you might think, what about if I had a graph like of this form? So for example, if I had a graph like this, 2e 3x plus 4. And you might think, oh, I don't know how to do this one because Stephen only showed me the 4 possibilities that are like this. Well, for example here, what you could do is a small rewriting. You could write this as 2e 3x e4. And this is y equals 2e4 e3x. So you got y equals this number, 2 times e power 4, e power 3x. And you realize it's the same form. This is like the a, it's just a number, and this is like the b.
So this moves something, the graph?
Yeah, so which of the 4 graphs is it? The 1, 2, 3, or 4? Which of the 4 graphs?
Go back.
Yeah, go back. So 1, 2, 3, or 4. It'll be 1 because this is a positive and this is a positive.
How do you know it is positive?
This one here, sorry, the number in front of the x is a positive. It's all we care about. So because this number is positive and this number is positive, it'll be the first type of graph. Yeah, to the original here. Yeah, so something like this could easily be changed into a form like this, what you had originally. That's what I'm saying. So I'm just saying you may need to slightly rewrite it. That's all. You see, because what I did was I took the plus 4 and I pulled it out here by using rule. Which rule does that? Which rule? The first rule. And then all I did was I just multiplied this by this first. Because if you have A multiply B multiply C, that's the same as A multiply C multiply B. It doesn't matter. And then I just grouped them together. And I call this piece here the A, and then I call that piece there the B. It's the same form. Yeah? You got that? Yeah. So, what I'd like you to try, hey, listen. These are very short to do, so A, B, C, D for each. They are very short to do. I was talking extra slow to pull these along. We'll probably get that done in 5 minutes, I'd say. Okay, do you have a class in here next? Alright. I can close this now? Yep. No, forget about that. Wait.
Why do we need e-graphs?
Why do we need what?
E-graphs.
They're in fact a very important type of graph in maths. And not until we do calculus, it's not until calculus that we realize how important they are. The graph is a very interesting type of graph. It doesn't seem interesting now. Later it will be interesting. At least to me anyways.
Because in method is the biggest trouble there.
Not,
Something confusing.
it can be confusing. It's very important in calculus. Yeah, yeah. And in fact, it's also important for your assignment as well.
How's that?
E will appear in your assignment. Yeah. So it's important for that too. I can close this now?
Mhm.
Yep.